Hi everyone, let's get started. In this video, I'm going to talk about very useful data structure called set, and we're going to implement it using arrays. So what is the set, and what are the common operations of a set? Well, what we know about set from Python or computer science in general is that, first of all, there is no notion of order. With sets, we can answer questions whether an item is in the set, yes or no. Also, there are no duplicates in a set. So, for example, there can only be one apple or one orange, and things like that. All right. So we're going to implement the set data structure using arrays. But just for your information, the collections framework in Java actually already supports and implements sets. And behind the scenes, actually I have no idea how exactly they implemented it. It's very likely that they used an array, something that we can check later. All right. So what are the operations supported by the collections framework? Operations like add. You can add an item to a set. You can add multiple items. In fact, you can add a set to another set. You can remove random. Oh, I never knew that. I never used this one. You can remove an item. You can use an union operation. Check whether the set contains an item. Lots of operations, but there's just too many. And in fact, we're going to focus on a subset of these operations. Specifically, we're going to write a set implementation that is going to be backed by an array. We're going to call our class ArraySet, and it should support only the following operations, such as isEmpty, whether the set is empty or not. It will return a Boolean value. We want to be able to add an item, want to check whether the set contains a given item, and want to be able to remove an item. In addition, we want our set to implement the iterable interface. So the idea here is that we want to use the for each loop, the enhanced for loop, and for that to work, we must implement the iterable interface. And just like any other collections framework, nobody is creating an array, an empty array. Usually behind the scenes, an array is created with some initial capacity. And then if there's no room in such an array, then the capacity is doubled. We're going to demonstrate our functionality by adding/removing elements, and we're going to iterate over its elements using the for each loop. So that's the plan. Let's get started. As usual, I'm going to create a new project. Let's call it demo. All right. So far so good. So let's start by creating the driver class just to see what is it that we want to implement. I'm going to create the main method, and this is what we want to do. We want to create an array set, and for our demo purposes is going to hold integers, and as we all know, we can only use objects. We cannot use primitive types here. Let's call it set equals new array set. All right, and our ArraySet class does not exist yet, so let's go ahead and create it in the same package. All right, so far so good. By the way, if we want to follow the naming convention which was suggested in one of the earlier slides, if you have a collection of if your class represents a collection of elements, then a better identifier would be E, which stands for like element. All right, so this gives a hint to the reader of this code that it is indeed a collection. All right. So then we want our class to implement set operations. So for example, if we wanted to implement the set interface provided by the collections framework, let me show you. In that case, we would have to implement tons of methods, toArray, and then retain all and so on. So this is not what we want. As a result, since we want to focus on a subset of those operations, we're going to create our own set interface. I'm going to call it mySet. Let's go ahead and create this interface called mySet. And mySet is going to include the following methods. The first one is going to be empty. The next one is going to be add method. We want to add like an item of type E, which is a generic type, and we want to return a Boolean value. So if we are able to add and then what we want is there's going to be interface over elements of type E, and let's update our class declaration before I forget, and also let me add the remaining methods that we want to support, such as contains an element of type E, and finally want to be able to remove an item. Alright, and again, we're going to return a Boolean value. If we're able to successfully remove an item, we're going to return true, otherwise we're going to return false. And so obviously we got a compiler error, and the reason for that is that since our class is concrete, we must implement all the methods in mySet interface. Oops. Okay, let's implement, and there are 4 methods. All right, so before I start implementing those interfaces, let's also introduce the array that we're going to use to manage all the elements in our set. So I want to follow encapsulation, so I'm going to say private, and it's going to be type E, and it's going to be an array. Let's call it data. In addition to that, we must maintain our private attribute, internal attribute, which is going to hold the actual number of elements in the set. All right, so let me show you. Let's call it size, and it's of type int. All right, now let's go ahead and add a constructor. All right, so I'm gonna go ahead and create a constructor for our array set, and then this constructor is going to accept a parameter which is the initial capacity. All right, so our array, we're going to create an array of size initial capacity, so that for most intents and purposes, when anyone adds element to our set, we don't every time create a new array. So it will have some initial capacity. And what is the code to create an array, a generic array of type E? All right, so you may think that this is the code of size initial capacity, which is in fact an error. This code is incorrect. Due to type erasure, we have to write code that looks like this. We are going to create an array of type object of the right size, and then we're going to cast it to an array of type E. And we also want to initialize the size of our array, which is 0. So even though our current capacity is n elements, but the actual number of elements is 0. All right, and now I also want to create an array. So the reason I have this compiler error is because if you look at the driver code, I want to create an array of with no argument. So we must add an array of no args array. Okay, so let's do it. ArraySet, no arguments there. And then what I want is I want to take advantage of constructor chaining. And when the user does not explicitly say the capacity, I want to use the default capacity, let's say 5 elements. Okay, so in order for me to reuse the other constructor, I'm going to use the keyword this, and then within the parentheses I'm going to pass 5. So 5 is going to be the default capacity if the user does not specify explicitly how many items should be there. All right, so far so good. We got rid of the compiler error. So now it's time to implement our first method, which is empty. So what should this method do? Well, if there are no actual elements in our set, we should return false. All right, how do we know if there are elements in our array? Remember, this is why we introduced this variable called size, which is going to hold the actual number of elements, which is 0 at the start. So one possible implementation for this method is return where the size is equal to 0. So if its size is equal to 0, then the set is indeed empty. Otherwise, it's going to return false. All right, I think we wrote enough code to get started. All right, so let's, I'm gonna add some useful information to the user. So at the start, we created an empty set, comma, and then inside the, angle brackets, I'm gonna put the actual elements that are expected to be in the set. And at the start, it's going to be empty, so no elements inside the angle brackets. All right, and then let's print out the actual set. We can also print out the result of the first command, which is whether the set is empty. Okay, so plus set.isEmpty. All right, so this is the starting code. Let's run it and let's see what happens. All right, so this is information to the user. Then we're seeing like some weird output, but the set is indeed empty. So this is awesome. But obviously I don't like what I'm seeing on this line, on the second line. So let's go ahead and fix this. And I won't even ask you how to do it. I think by now everyone knows that in order to control the output of a print statement when we pass an object, we need to override the toString method. All right, so let's do just that. Let's go ahead and add the add override annotation, which is a hint to the compiler that what we're about to do is we're actually going to implement a method. All right, so it's going to return string. I'm going to say toString. All right. So let me implement like a simple version of toString method for our class. Okay, so I'm going to maintain a variable called result. All right, and let me show you. You can control a string using like string.format method. So the content is going to be set size / capacity colon space, and then followed by two numbers, the set size / the capacity, and then followed by a vertical bar, and then within angle brackets I'm going to list the actual elements that are currently in my set, comma, let's add the size, and the capacity is going to be the length of my array, semicolon. Now in the and before I forget, at the end, at the bottom, we're going to return our result, our running variable. So now I'm going to, and before I forget, before I return it, let's append the right angle bracket, because we had the left angle bracket here. Here's the right angle bracket, and now I'm gonna have a loop for int I equals 0 while I is less than. So here's the question: when should we stop? Okay, so in the loop, I want to iterate through each element in my array. But how many elements are there? Well, despite the fact that my capacity is, let's say, 5 elements, the actual number is stored in the size variable. Okay, so that is crucial. All right, so here's what I'm gonna do. I'm gonna append the current element in my data, in my array, at i's position, and then if I is less than size -1, I'm gonna append, I'm gonna put like a space in between. Again, this code, this toString function is not the focus of this demo. I just showed you how you can, implement it and to make, the output readable. So let's rerun the code. And now we have created our empty set. As expected, it is empty, and the set size is 0 and the capacity is 5. It is indeed empty. All right, so hopefully we're on the same page. We're about to start implementing the first meaningful method, which is add. All right, so here's the idea. Okay, remember, keep in mind that a set is a data structure that does not allow duplicate elements. How do we know whether the set already contains a given item? Well, let's say that if we had a method called contains, and if our array contains this item already, we're going to return false. Okay. Furthermore, what else can go wrong? If we are at capacity, meaning we had 5 elements initially as our capacity, and then we already have 5 elements in our set. If we're there, we need to expand capacity. Okay, so let's do if size is the number of elements is equal to capacity, which is data.length. In that case, let's go ahead and expand capacity. Okay, and on the exam, you're gonna have to implement it in line, but for readability purposes, I'm gonna introduce a method called expand capacity. All right, and let's just go ahead and add this method, which is going to be private. We're going to implement it in a moment. So assuming there are no duplicate values and we have enough room in our array, let's go ahead and add this item to our array. So data at size, okay, is equal to item. And one last thing, let's not forget to increase the size, because we just added the item to our array. So size plus. Okay, and finally, after going through these steps, we were actually able to successfully add an item to our array, which is why we need to return true. Okay, and one last fix, I guess, refactoring for our code. We know that we can use a post increment operation right here, and we can get rid of this line. And this is the final version, I guess, of our algorithm. And maybe for readability, you may prefer to see code like this. Up to you. Maybe, arguably, this is a little bit more readable. Okay. So now let's go ahead and implement the expand capacity method. So what is the purpose of this method? When we encounter a situation when we are at capacity and there's no room in our array, we need to increase the size of our array. And usually you do not want to increase it by 1. So let's say the size was 5, and then you create a new array of size 6. That would be silly, because the next time you need to add another item, you're gonna have to create a new array and so on. So instead, in our case, let's just double the size, double the capacity. All right, so for that purpose, I'm gonna create a temporary array of type E, temp equals, and remember, due to type erasure, we have to run code like this: new object with the needed size. So what is the size that we want? Well, we want to double the capacity of our existing array, so data.length times 2. All right. Furthermore, let's not forget to copy the old elements from the previous array to our newly created array. So we're gonna have a loop for int I equals 0 while I is less than. Again, less than what? Well, in this case, the size and data length will work, but let's keep it less than size. Oops, sorry. Int I equals 0, less than size, plus I. And what we want is, we'll now copy the elements from the old array to our newly created array. And before we forget, let's update our reference data equals now to the newly equals the newly created array. So this is our expand capacity. Cool. Yeah, the only method which I think we haven't implemented yet is contains. All right. Here's our contains. So what is the logic for the contains method? So the idea here is we want to go through each element in our current array, and then we're going to check if a given item is equal to the provided item, and if so, we're going to return true. Otherwise, if we go through the whole array and we haven't encountered a similar item, we're going to return false. So here's our loop for int I equals 0 while I is less than size, plus I. So here's what we're going to do. If data at i's position is equal to the incoming item, how do we do that? Well, we use dot equals. That is the only way to compare the contents of two objects, because if we used equality operator, then we would be comparing their memory addresses, which is not what we want. We actually want to compare their contents. So dot equals item, and if that is the case, then we're going to return true, because we found this item in our array. Otherwise, if we went through the whole array and we never encountered a similar item, we're going to return false. Cool. All right, so now it's time to test our newly created functionality. All right, let's add a line. In fact, I'm going to copy these 3 lines. So let's add another information to the user that we added an item, and let's say we added 10. Okay, so then we can say that added. Were we able to actually add 10 to our array? So we're going to do set.add 10. So remember, our add operation not only adds an item to the array, but also returns a Boolean value. If there was a duplicate, we're going to return false. Otherwise, we're going to successfully add an item and return true. And we should be able to add 10 because we have enough capacity, and initially our array is empty. All right. Yeah, cool. Yeah, let's run this code. Let's see what happens. All right, so at the top we have created empty set, initial size is 0, capacity 5, it is empty, and now the plan is to add 10 to our set. We're able to add it, yes. So the new size is 1, the capacity 5, and this is the content of our internal array. Is it empty? It is no longer empty. Cool. I think our code is working perfectly fine. So let me go ahead and add a few more items. So let's add 20. Okay. and then let's add 30, and then let's add 40, and then let's go ahead and add 50. Okay, so now we are at capacity, and let's attempt to add a number, a value that is already in the set, just to test whether our set takes care of duplicate elements. So well, in this case, we should not be able to add an item like 50 again, or 40, or whatever. I can keep 50, sure. All right, so yeah, I believe our code is written well, so it should work. Let's run this. All right, let's go all the way to the top. Again, this is when we create our empty set, initial size 0, capacity 5, and then we were able to successfully add 10. Our size increased to 1, capacity is still 5. And then we added 20. We're able to add true, the size is now 2, capacity 5, and these are the actual elements in our array. It is no longer empty. We added 30, size 3 out of 5. We added 40, size 4 out of 5. We added 50, size 5 out of 5. And now we are about to add 50 again. Were we able to add? No, because 50 is already in the set, so we're still at size equal to 5, and then the capacity is still 5. Cool. I think so far so good. All right, now the cool test. All right, now let's add another value to our array, like 60. We should be able to add 60. And what should happen here is the new size of the array of the set should be 6, but the capacity should double and it should be 10. So that is the plan. Let's run this code. Let's see what happens. All right, were we able to add 60? Yes, we were. True. The new size is 6 and the capacity is 10. And these are the actual elements in our array, which is exactly what we expected. Is it empty? False. All right, so with this, I believe that our add functionality is correct. Now, let me show you the next step. What else do we want to implement? Okay, and which is, I want to be able to implement the test for the iterable interface. Okay, so here's what I want. For integer element in our set, I want to print element plus space, and then I want to add like an empty line. All right, so this is the test for whether our class implements the iterable interface, and it doesn't, which is why we have this compiler error. Okay, so now we need to go ahead and implement the iterable interface. All right, so how do we do it? So we actually have two options to indicate whether our set implements the iterable interface. We have two options. So we can either say that our array set implements my set. In addition, it also implements another interface which is iterable, and that would work. Or we can say that my set interface extends iterable interface. So out of these two options, which are really kind of similar, the difference is subtle. Which option is better? Okay, so I claim that as a designer, I think it will be cleaner if we said that my set extends iterable, and since we want to compare apples to apples, I'm gonna say iterable. We're gonna compare to elements of type E. Okay, so now we got a compile time error, and the reason for that is because now we have added responsibility. Now ArraySet implements mySet, which in turn extends iterable. All right, so if I hover my mouse over here, our class must be either declared abstract or implement abstract method called iterator. So if you remember, we did talk about the iterator interface, and let me show you how we can implement this idea. All right, so here's what we're gonna do. Maybe at the bottom of my class, I'm gonna override a method called iterator, okay, which should return an instance of iterator interface, which is generic. So let me go ahead and import this class. So let's go. So this is we don't want the collection set. So iterator is an interface which has multiple methods, including hasNext and next. It also has a few default methods. Well, that basically means that we must implement only these two methods, hasNext and next. All right. Now going back to my class. So iterator must return a new instance of type iterator. All right. So how do I do that? So here's the code. I'm going to return a new instance of a class that implements the iterator interface. I'm going to call it ArraySet iterator. All right, I'm literally creating a new instance of a class that is supposed to implement the iterator interface. All right, so let's go ahead and create this class. And we have two options. One option is to create like a separate class which will live in its own file, or I can create an inner class. And that is the option I'm going to pursue. And the reason for that, I believe this is like an internal implementation detail. The world does not need to know how I implemented my iterator class, which is why I keep it inner. All right, so now this class in turn must implement the iterator interface, and as I mentioned to you earlier, it has two methods that we must override. One is called hasNext. So for now, let me just return false. And another method is called next, which is supposed to return the next element. Let me for now return null, just to keep compiler happy. Oh, my bad. Public. All right. So far, so good. And in order, so basically the idea here is this. I'm creating a new instance of the iterator interface. And within this instance, I need to maintain the current position in our array. All right. So for that, I'm going to introduce an internal attribute called position, and I'm going to initialize it to 0. All right, I'm not even going to bother with creating a constructor. This is, by the way, is known as eager initialization. All right, so how do I know that we still have room and there are remaining elements in the array within this current iteration? Well, the answer is, if our current position is still less than size, then we're good. But if our current position is equal to the size of our array, to the actual number of elements in our array, then there is no room. So we're going to return where the position is less than size. And size, remember, is the actual number of elements in our array. Okay? How about next? When can we return the next element in our iteration? Well, we can do that as long as there are we still have remaining elements. Okay, and if that is not true, then we can throw in this exception. We can say no such element exception, and we can add a message: there are no more elements in the set, exclamation point, semicolon. Okay, so assuming we still have remaining elements, let's go ahead and actually return the element at our current position. So data at position. Okay, so it's all good. However, let's not forget to update our current position. So after we return the current element, we need to update our position, and we can use a postfix, post increment operator, like so. All right, so with this, I think our implementation is correct. So let me run this test. So here's iterable test. We had 6 elements in our set, 10 through 60, and it worked. Again, let me show you how we implemented support for enhanced for loop. And first of all, we said that ArraySet extends iterable interface, which gave us extra responsibility. So now our ArraySet class now must override this iterator method, which returns a new instance of the class that implements iterator interface, and we chose to implement it as an inner class. Okay, so here's our private class ArraySet iterator, okay, which implements iterator interface, which in turn means that we must implement 2 methods, has next and next. So one subtle point, which I'm not sure whether it is clear or not, but when you have an inner class, that class automatically has access to the attributes of the outer class. And I'm not sure if you realize that, but I can refer to its attributes like size, which belongs to the array set, as well as to the data array. So the fact that our class is ArraySet iterator is inner to the array set class, that means that we have access to its attributes like size and data. Cool. All right, so hopefully you stop this video because it's been like so much information, and you're not as exhausted as me, but we in fact have one more method to go, and this is the final method, which is remove. All right, so now we must implement the remove functionality. All right, so how do we do it? So the idea is like this. I think we want to go through the loop. So there are multiple ways to implement the remove functionality. Here's the approach I want to take. I basically I want to find the element in my set that is equal to item. Okay, and so then the question becomes like, what do I do with this information? Do I set this element to null? Well, that wouldn't be a good implementation in my view, although it is possible. But all of a sudden we will have like holes in our code, and then we'll have to take care of make sure that whenever we deal with an element in our set, that it's not null. So that is not very convenient. Another option is take the last item in our set and place it and overwrite the existing element. And if we do that, let's not forget to decrement size, and let's set the last element to null because we just moved it. We overrode the existing element with the last element in our array, and now that we moved it, let's not forget to set it to null. Okay, so this is the idea. I hope it's clear. Let's implement it. So I'm gonna have a loop for int I equals 0 while I is less than size, as usual, right? Because size indicates the actual number of elements in my collection, plus I. Okay, if data at i's position is equal to the incoming element item. So here's what we want to do. I want to overwrite ith element with the last element. This is the idea. So data at I is going to be equal to data at size minus 1. Okay, and what else? We want to set data at size minus 1 to null. Let's not forget because we removed it. And then we can increase, let's not forget to decrement size. And we can return true that we were able to successfully, remove the element. Otherwise, if we went through the whole array and never found an equal element, then we're going to return false. All right, that is the idea. Well, it turns out that we can actually simplify this two lines of code into 2. Okay, and here's what we can do. I can so I want the position at size minus 1. What if we pre-decrement size like this, and then our size is now has the correct value, and I no longer need to decrement it because I already did. All right, and that is the implementation for the remove method. Okay, if you're struggling with this implementation, you can take a pen and paper and then see what are the steps that you need to take to override the ith element with the last element, to move the last element and override the ith element. And you need to set the previous last element to null. You need to decrement size as well. All right, now let's add the code that would test the remove functionality. Okay. All right, so I'm just gonna copy this, I guess. All right, so now we're going to removed. Oh, by the way, I think for readability, let's say added 10. Okay, I think it's clear what we're adding and removing. So removed, removed. So we're going to remove, let's remove 10. Okay. So what I expect to see is I'm going to take the last element, which is 60, overwrite 10. I'm going to decrement the size. This should be the expected content of my set. All right. Similarly, let's remove let's remove 30. Okay, so if we were to remove 30, we would have to take 50, overwrite 30, and then decrease the size. So we should be able to remove 30. Okay, so that's an interesting test. Now let's remove, let's say 20. If I were to remove 20, I would move 40 here. Okay, something like this. Now let's remove 50, which is the last element. Let's see if our code can handle that. And we should just say that. Okay. What else can we test? What if we remove 40, I guess? If we were to remove 40, we should be left with 60. Now we should be able to remove our last element, which is 60. Let's remove 60. And we should be left with an empty array. And now the final test. Let's remove 60 again. And in this case, it shouldn't remove anything because we don't have 60. All right. So I think we have enough tests. Let's run this. I hope it all works. All right, let's go to the very top. At the start, we created an empty set. Initial size is 0, capacity 5. We added 10, size 1, capacity 5. We added 20, size 2, capacity 5. Added 30, added 40, added 50. And then we try to add like another 40 or 50, like a duplicate value. We were not able to do that. And then we added like 60. So our new size is 6, and then capacity was doubled. And then we had the iterable test, and now the removal tests. All right, so first we wanted to remove 10, and the logic we implemented was that 60, the last element overrode 10. So now our new size is 5, capacity 10. And then we removed, I believe, 30. So 50 overrode 30, and then the new size is 4 out of 10. And then we removed I guess 20. So then 40 overrode 20, and these are the remaining elements. The new size is 3 out of 10. And then we removed, I guess, 50, which is the last element, and now the new size is 2 out of 10. And then we remove 40, size 1 out of 10. Then we remove 60, now size 0 out of 10. And then we attempted to remove 60 again. We were not able to remove it. The size 0 out of 10. Is it empty? We're back to true. All right, so this was a long coding example where we implemented my set interface, which only has these 4 methods. We had to add one extra method, which is expand capacity, but these are the methods that are exposed to the user. And here's our array set. And behind the scenes, this is a generic class. We have a type parameter. We give it a proper name, which is E, because our class represents a collection of elements of type E. Here's how you declare an internal array of type E. When you do that, you must add like an extra attribute to maintain the current number of elements in the array. And then I implemented like a constructor which has some initial capacity, and this is line. You can get bonus points on the final exam if you remember how to create an array, a generic array. Okay, and so what happens when the user does not explicitly specify the capacity? Well, we took advantage of constructor chaining, and our default initial capacity is 5. is empty, return size equals to 0. And then this was our first non-trivial method where we want to add an item, and if our set already contains an item, we're going to return false. If we're at capacity, we're going to expand capacity, and this is the actual line of code that adds an item, and we're going to return true. Expand capacity, we're creating like a temporary array of type E of where the size is double the size of the current array, and then in a loop we are copying elements from the old array to the newly created array. And let's not forget to update our data attribute. This is the code, which is not too difficult. We want to check whether our array contains a given item. So in a loop, we keep checking whether current item is equal to the incoming item, and if so, immediately return true. Otherwise, we went through the whole array, never found it, we're going to return false. And our final method was remove. And the logic here is that if we find an element that is equal to the incoming element, then we take the last element and move it, override the existing element. To string, you can ignore. This is for demonstration purposes. And here's the final piece. If you want your class, which represents a collection, to support like a enhanced for loop, your class must implement iterator interface. Iterator interface and return a new instance of iterator, and we chose to implement it using like an inner class. So here's our inner class implements iterator, which in turn means that you must override two required methods like hasNext and next. And when we did that, we introduced our own attribute to maintain the current position in our iteration. We initialize it to 0, and then hasNext is when the position is less than size. Then we have remaining elements in our current iteration, and the next method, we first check, do we have the next element available, and if not, we're going to throw an exception. Otherwise, we're going to return the element at the current position, and we're also updating our position accordingly. And the driver class was just a way to test the created functionality, and hopefully this test was thorough and we can trust that our implementation was correct. All right, so this is it. I went a little bit over the time limit. When I do it in class, usually we never have the time to finish the remove method, but hopefully all of this code is going to be uploaded to the modules as usual, and I highly recommend that you implement all of it from scratch. You don't have to do it in one take. You can take multiple days, but I highly recommend that you know how to implement a set data structure using an array, and it takes time, but if you know how to do it, you'll be much better prepared for the coding portion of the final exam. All right, that's it for today. I hope you found it useful. I'll see you in person next week. Bye, everyone.